So last week I have published tutorial. Yeah. So yeah, today I think after today's session you will be able to do the most of the questions. So today I will teach you about uh, Boolean algebra and how to simplify a Boolean expression. So apart from that, do you have any questions of the last week uh, about the logic gates? No? So last week we did about gates and some operators. Yeah, today uh, I will go through about the Boolean algebra and how to simplify your Boolean expression and sum of product of some m commandments. Yeah. So I think we won't able to do this one Queen McCluskey method. So probably you will need to self-learn this method. So uh, in Kanu maps, we will learn about how to deal with four logical operators, not operators, four logical variables. So after that, there are more than four, and we need to have some kind of a method to simplify a given uh, Boolean expression. So yeah, maybe we'll need to self-learn this queen matrix. Okay, my recording. Yeah, I'm recording. So if you have any questions, please let me know. So based on the, you can see me, right? Yeah. So based on the last ML, so draw the truth table for this equation plus. So draw the truth table for this expression. So there are only two variables A and B. So that means since how many rows should be two. Okay, so here n is two. So it means two means two of four. Mm, okay. Uh, E zero zero 1 So it is A dot B bar. A zero B bar. Since A is zero, this should be zero. Here B is zero, so this also zero. A zero. Here it's one. Here one. B A 0. This will be 0. Here say will be 0. What about AB? So then X is the logical of. So either one is true, then we can say it is true. So here all are zeros. So 0. Here there is 1. So it is 1. Here it has 1. 1. Here it has 1. So by looking at this, we can say it is OR gate, right? So it will be equal to empty A plus B, right? So there should we have some kind of a mechanism to derive or simplify a given expression into something. So here, by looking at this output, we can simply identify this is a subject. So in Boolean algebra, we gonna learn about how to gonna simplify this one. Yeah, before going into the laws, I will explain two concepts. So one concept is sum of products. Second one is product of sums. So what is the sum? Sum means O gate, and product is simply empty. And now sum of product. some summation of product here. These are products actually, and we can have a sum. So this x is the our final output of the summations of these products. So if some expression has so inside has only products like this a b or a b c or any kind of variable, and there are only fancy products here, and all these uh, parts are uh, connected by the O gate to summation. Likewise, so that is sum of product. So product of sums. So it means should we have finally a product like this, and let's see that part. Put it here. Product of sum. So product means this and sums. So inside that each product there should be sums. There can be either more than one variables. So we can be so like that. Here we have sum of products. Here we have product. These are all the products. Product of sums. Sums. So in this scenario, we can see this row has output 1. And this row also has output 1. Row also has this output, right? So we given a table like this. Let's consider. So here we are running row 1, right? So you have given a truth table like this. Here, this has this row has the output true. This also have output true, and this also have output true. So we using the sum of products by using sum of products, we can derive the expression. So our expression will be here is 1. So we need to if this value is 0, we need to get the opposite one. So how we can get this value true? By using the not gate of uh, the bar operator. So that means a bar multiplied by b bar. So it is dot operator. A bar dot B bar. If this one to be true, the product of these variables also should be true. So since the A is 0, then A bar will be 1 and B is 0, so B bar will be 1. So that's why we take A bar dot B bar. Then this one here A bar into B, and we can remove this one since it is false, and you can take this one. So it is AB. So actually this is the expression by using sum of products, right? Then we can derive the equivalent expression by using the product of sum as well. Right? So in that case, we are taking the negative values or the false values, these ones. So for this particular case, right? So it is A. Since this one is true, we need to negate that. A bar plus B will be our actual final output. Since other rows are also all other three rows have operator 1. Final output 1. So this will be equivalent to A bar plus B. And you can say this is also a sum of products, right? Because there is only two operators, A bar, B, and based on the last last session that we had in last week. So this will be equal to A bar plus B dot B. So it's also like a sum of product. But the problem is, yeah, in this case, this expression A bar plus B will be both sum of product and product of sums. Because the whole thing can be a product of 1. 1 can be simply say that A plus A. So I will explain this one. So it can be as this as well. But you know, A plus 1 plus A will be always 1. So you will learn about those rules today. So for the simplicity of so yeah, I will give you another example of this product of sum. This one as well. We will have a clear idea. So product of sums, we are taking the false outputs for these ones will be taken into the product of sums. Since if A is true in products of sum, we need to negate that. So that means A bar plus B into here A bar plus B bar. So for doing more simplicity, we can do this one. So there is not going to be any harm. So here means A dot B B bar into not. Here A dot B dot K. Right? So what that means? A B bar and AB, but since this output is false, we need to negate the whole thing, right? So again, we can redo the apply De Morgan's law. So that means A bar plus B, since there is double bar, so it will be removed. And here A bar plus B bar. So actually it's our final output. We can simply write it by the first element. Yep. So even we can so in here so only for your understand. So this the negation we can take outside. So that means all negation A B bar plus B A B. So we apply De Morgan's law, what happened? So if we need to do the negation for each operand, so that means A B blah, and this will be changed A B, right? So the same. That means when you're learning sum of products, we only take the values that will be the final output that will going to be true. And if this one is 0, we are going to negate that. So here also we can do the same for negative values, but we need to put this not since the final one is false. So even that it will going to change into a product of sums. So that means if there are expression in sum of product, we can able to rewrite it product of sums as it and do the same. There is a product in there are expression in product of sums, we can rewrite it to back into some product as it. So finally, so sum of product will consider output of ones only, and product of sums we will consider outputs of zeros, right? So if you have any questions, please ask. So I will give you an exercise. Then I will give you equation of 4 variables. That means so our function has 4 variables. So the expression is a b bar c and a bar b c bar d bar. A c bar So there are 4 uh, subparts and expression, and there are 4 variables as A, B, C, D. So first one is A, B bar, A bar plus B bar plus C, and the second one A bar plus B plus C bar plus D bar, and A bar plus B bar plus D, and A plus C bar. What you need to do is, it is in the product of sums. So this expression is product of sums. You need to convert it to sum of products. So put this. Yeah, Q is 0. And next up, 1 plus 1. What it's gonna be? It's gonna be, as I explained earlier, 1. Third one, 0 plus 0. Now it is operator 0 or 0, or otherwise 0 plus 0. So it will gonna be 0 again. The fourth one, 1 dot 1. That means 1 and 1, or others we can say true and true. So it's always gonna be true. These are logical operators, right? This means false and false. So it should be false. This one true or true. So let's prove. This false or false. Again false. This is true and true. Then it's going to be true. This is actually this is not in mathematics. In mathematics, you have to say 1 plus 1 will be 2. But here it's not that one. This is Boolean. So Boolean, that means there should be only true or false. Or otherwise, Boolean means there should be only 2 outcomes. It should be true or false. T, and this is a true or false. Or that we can say in by using 0 and 1. So 0 will be used to identify false. 0, 1. Boolean means only 2 outputs. 2 outputs that are true and false. So we can denote it by true and false, T and F, and 1 and 0. So this means 0 and 0. So it should be 0. Otherwise, we can say T, false, F, and F. So it should be, that means false and false. Here it's true or true. So it should be true. Here it's false or false should be false. Here, true and true should be true. So the 1 and 0, that means true and false. So uh, uh, Boolean not going to have yeah, it's not going to any matter if we change the side aspect. That means 0 and 1. So it means false and true. So what will be the output? It should be false. Means the AND operator or dot operator. Likewise, 1 plus 0 means true or false. Again, false or true. False or true. So I will explain it again. True or false or 1 plus 0 in Boolean is equivalent to false or true. So output will be true. So you need to remember these 6 postulates when you are doing a simplification. Right? If you have any question, please ask. Questions up to now. So now I'm going to teach about the Boolean laws. So what you need to remember is there will be only 2 outcomes, either true or false, 0 or 1. Laws of Boolean. So first one is commutative. So you already done this one. That means we take 2 variables, 2 Boolean variables, and we say a plus b. So it will be equal to b plus a as a. So same for dot operator. A O and B to B and A. So this is the commutative law. So the second one is the associative. Associative law, right? So what that means? Say A plus B plus C is equivalent to A plus B plus C is how. That means we can first do this part, and the whole thing will be can be do this part, and it will be equal to we do the last part first and do this part. So should be equal to this as well. So that means we can do this one and multiply with C will be equal to this one as. So these 2 laws are very simple, and to remember. The third one is the very important law of distributive law. So if remember, we have only two outcomes in the Boolean algebra. In this way, we can simply distribute this A inside this B and C. That means removing this bracket. So that means AB plus AC. And this one. Right. So this will be some kind of hard to understand, but A plus B and A plus C. So let's do this one. So this should be A plus C plus C, A plus C. So here A and A. So that means A plus AC. Here it should be AB plus B. And what we can do is we can take so I will take this part. So here what is the output? A. This is A into A. That means A plus AC plus AB plus BC. Right. So what we can do is we can remove or take this A out on the bracket. This will be 1 plus C plus B plus BC. Since there is this 1, so 1 plus something, 1 or something. That means this whole part will be going to replace by 1. A plus BC. Since there is 1 here, so that means all things will gonna be true for this part. So we can replace it by 1. So that means A plus BC. So that is our answer. Right. So yeah, in here we have used this law, identity law, that is the fourth one. Identity law. So what that means is A plus A will be equal A, not 2A, right? In mathematics, it's going to be 2A. Here, it's A. That's why we can see this here and under A plus A will be equal to A, not A squared or something. Only A. So A squared in mathematical way. Here it's only Boolean algebra. So it happened, yeah. So the next part. So these laws can derive, this law can derive by using this identity law and distributive law. So then the law is this income. Income is redundancy law. So redundancy law, that means A plus AB. So as you aware, if we take out this A out of the brackets, this part is going to be 1 plus B. So 1 plus something is always 1. So the final answer will be A. So it is same for this one as A plus B. So this one also will be A. How will that happen? So here it will be A. Here distribute this A into here. This will be A plus AB. Then we can retake out this A. Then it will be 1 plus B. So 1 plus B will be 1. So it will be A. That is redundant. So redundance means B. If we see this part A plus AB, we can remove this B. And even that in the outside of the bracket there is A and some A plus B. So it will be need to have this one and this one side bracket. This one and this one. Then we can remove the other part. Yeah. So the sixth law. So we have already used that law. That is De Morgan's law. De Morgan's law, De Morgan's theorem. That is A plus B bar is equals to AB bar B bar A bar B equal to A bar plus B bar. If you have any questions, please let me know. Questions up to now. So there are no names, but by using these theorems, you can identify these ones as well. So the first one is say A B plus A B bar, right? So as you are aware, you can take this A out of the bracket. So then what will happen? B plus B bar. We have taken out this A, then B plus B bar. So what that means, if the variable takes 0, then the other variable B bar will be take 1. And if it is 1, then so it's going to be 0. So the summation will given 1. B bar, B plus B bar. B bar, B plus B bar. So it's same for the other variables as A bar plus A. So these whole will be 1. So in that case, we can replace this one with A. It will be A. So yeah, also have the same characteristic. So this is also going to be A. How it happens? So we can simplify. So this is going to be A B bar plus AB plus what will happen? B dot B bar. So here what will happen is it's always going to be 0. B plus B bar will be 1. B dot B bar will be 0. right? So this part will be 0, 0, and 0 plus something. Always going to be that something. We can remove that one as so from here. If we take out A, then it will gonna be 1 plus something. Take out A, then 1 plus B bar plus B. We do not need to reduce it to more further since this is A plus something. It's always gonna be 1. So here also we can see 1, 1 plus 1 also 1. So it is gonna be A. And the other thing, A plus 0 is still gonna be A, and A dot 0 is gonna be 0. Right? Actually, you can't really apply directly these rules, but you can identify or uh, by using the already use laws already in given rules, you can simplify this expression into these ways, and you need to keep an idea about these ones. And this one, A plus A bar will be 1, A dot A bar will be 0. On this one, so let's say A plus 1 will be 1 always, and A dot 1 will be A. Do you have question, students? All right. Please let me know that the case, so I will move forward. So as I mentioned, so Boolean function can be writing sum of products. So we can say simply SO with sum of products, so or product of sum. Okay. So here, so for sum of product, we need to take the rows that will going to that will give the output 1 here, the output 0. And when you are asked to draw the logic gates, like maybe in the industry, it will be preferable to use NAND NOR gate, since by using those gates we can derive any gate. So I have given you 6 laws, and some characteristics is can be used to simplify a given Boolean expression. So I will teach about so I will give you all the details about all the necessary details about laws of Boolean algebra that we're going to use for the simplification by using algebra. So other one will be count maps, and as I mentioned earlier, you need to self-study this part. Queen-McCluskey method. So I will share that slides as well. We have last week we did this AND gate, OR gate, NOT gate, and now we did this laws. Snap gates, OR gates. So yeah, you can do this one. This is the way how to draw a uh, truth draw a logic circuit for a given output. So if it is in sum of product, you can easily draw the circuit in this way by using AND gate to get the product, and you can use a single OR gate to get the summation. And this is the product of sums implementation. And yeah, so we'll teach you about this count maps and decimal increment and this one. So the last part will be you need to do the self study, right? So I will give you a task. So you already learned about laws of Boolean and algebra. So by using uh, those rules, you need to simplify this expression. So I will that expression. So it has two variables, three variables A, B, C. The function is A plus B bar plus C bar into A B bar C. So by using the given rules, so what are those? Commutative law, associative law, distributive law, identity law, De Morgan's law. By using those theorems, you need to simplify this expression. So take a few minutes and do the simplification. Right. Student, did you able to do the task? Anyone? Yeah. Since we have less number of time, I will explain that one. So first, what you can do is by using distributive law. By using the distributive law, you can remove this bracket. So if A into A is A and or A and B bar C, then A B bar plus B bar into B bar. So it will be going to be B bar C is B bar A C bar. What will happen? C bar. So it will be zero. So what is not going to be zero. There is A. So what can we do? We can take out this A. So it's 1 plus B bar C plus here it's B bar the B bar C will be remain and B bar. So this whole thing will be 1. Output will be A B bar C. So did you understand? This C also should be there. But what happened here? 0, what happened? It happened this one. C, uh, C, the C bar multiplied by B bar C. So here we can see this C bar. So what happened? If the same variable multiplied by its so it's going to be 0, right? So this whole part will be 0. And here, what happened is, since A into A, it will be A. So since it is A, we can take it out and we can get the nice 1 plus something. So that something will be going to replace with this one. And this B plus C will be going to 4. Right? Please let me know if you have any questions. Please raise your hand if you have any questions or any doubts. So no one has any doubts? So please draw the truth table also. We're going to get this. Draw the truth table. This function a plus b bar plus c bar into a plus b bar c. Draw this one and this one as well in the same table. Then you can find out is this correct? So how can we draw the truth table? So there are 3 imports. So it will be 3. So that means 2 to the power 3 will be 8. So there should be 8 rows. A B. Yeah. Since 2 are equal, correct. It's the same. So AB, what we mean? B bar C, A plus B bar plus C bar. C, A plus B bar plus E bar. C, and this one. A, let's say this is x plus B, this is y, then it is x into y, x in y, right? So it is 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1. Here 0, 1, 0, 1, 0, 0. B bar C. So C is 0, should be 0. So B bar C, this will be 1. B bar. See, this is 0. C, B bar, 0 is 0. C0, 0. Here also 0. This is 1. This is 0. Since this is A plus something, so if the A is true, then it will always, this part will be true, right? And B bar, so it should be also true. Not these that ones. These ones should be true. And C bar, where C is false. Here C is false, so it should be true. Here A, B 0, this one also 0. Is 0. So only this one is 0. It is 0, 1, 1. Right. Then this one again A. So this always should be true. And BC bar, where this one here only is going to true. Other three locations, these are 0. Here 0, 0, 0. Right. So multiplication. Since it is 0, 0, this is 1, 0, 0, this is 1. So you can identify this both two, this one and this one is equivalent, right? So we can take our answer is correct by using the truth table as well. So do you have any questions up to now? So we can move to next part. We can simply say it in K-map. So anyone, did you heard about this? Please raise your hand if you never heard about Kanu maps. If you don't know about Kanu maps, please raise your hand. Only 4. So I see only 18 students. So others is what others? So that means more than half of students are know this. So count maps also, or simply K maps, also some kind of a table. So if you draw the truth table for n number of variables, so there are n number of rows. But in K maps, there are n number of cells. So consider we have only AB. So that means n is equals to 2. So there are 2 number of rows, that is 4 rows in truth table. And in count maps, there are 4 number of cells. Right. So how we can flow the table? So if you are drawing the truth table, we say like this: A 0 0 1 1 0 1 0 1. This is how you go to draw the truth table. But when you are doing count map, so what is this? And in this row, A is equals to 0, and this row A is equal to 1. And here, A is equal to 0, and E is equal to 1. Right? This is how you can draw a Kanu map by using uh, 2 variables. So let's say about 3 variables. N is equal to 3. That means N is 3, there are 3 variables to the power n be 8. So there should be 8 rows. That means 0, 0, 1, 1, 1, 0, 0, 1, 1, 0, 0, 1. So C 0, 1, 0, 1, 1, 0. So how can we draw 8 cells here? Simple, right? So what you can do is you need to aggregate two variables. So these are the 8 cells. So please closely listen to this one. So initially we need to start with the simple variable. So here, so for the simplicity, I will say this is A and this is A bar. And here, no, this is A bar A. Here it is B bar, C bar, right? So in other words, A is equal to 0, A is equal to 1. Here B is equal to 0 and C is equal to 0, right? So that's it, this set is here. And this one A is equal to 0, and we can only change one variable here. So that means B bar C, right? So that means B is equal to 0, C is equal to 1. And here we can only change again one variable to the adjacent cells. So here it should be BC. We cannot write BC bar because then it will going to have a wrong answer for our table or from count. So it should be, you can only change one variable at a time. So since we already changed here this one, we can change this. So it is BC bar. Then B is equal to 1, C is equal to 1. From here, we can change the C again. B C bar. Here B equal to 1, C is equal to 0. Right? So you need to keep an idea about that. One, you can change one variable at a time. So here we have changed C, here B, and here again C. Right? And there are three concepts. When you need to derive answer from max. It's P bar, C bar, P bar, C, B, C, B, C bar. So there is E bar, it's the first one is mapping. So that means you need to map to table to this map. Then the grouping. So I will explain this grouping means with an example. So the one is derived. So after mechanism, the mechanism is grouping, you need to derive the answer. So before going to example, do you have any problems? So you need to keep that in mind. So you can change only one variable at a time, right? So if you if you need to do it for four variables, so I will explain that one. Let's say if n is equal to 4, let's say A, B, C, right? So there should be 2 to the power 4. That means 16, right? So if it is 16, should be something like this. And this is A bar, B bar. Then will be only change one variable at a time. A, B, A, B bar. Here, C bar, D bar. Then C bar, D, C, D, C, D bar. Right? So only you can change one variable at a time. Then you can derive all the 16 operands. Right? So these keep an idea about that. And yeah, and recording. So in using count maps also you can derive the answer in sum of products and products of sums as well. So I will explain this one. Let's take an example. This one. A B bar plus A bar B plus A B. So we have already derived this one. So it should be A plus B, as I remember. So we are going to do that. So first draw the truth table. So table is A B 0 0 1 1 0 1 0. since A0, this 0, B0, this 0, AB 0, this is 0. Actually, this is AND gate, XOR gate. So this both should be 1. So the last part, it's 0, but AB is 1. So this is 1 as this is all. So how to draw it into the count map? So the for that is on pause. So you can take the first variable to the bracket as it. It's not going to do any harm. And you can do this one as well if you are prefer. So then do this one. So it is 0, 1, 0, 1. So here it is A, here it is B. So what this means is A's value is 0, and here A value is 1, here B value is 0, and B value is 1. So 0, 0, here 0, 6, or 1. Right. So this is how you can map the particular truth table in form. So you can do this way as well. It means here is A bar, A, B bar, right? This is how you going to map a particular table into a so please take 2 to 3 minutes and do this example. So it has 3 variables. So A, B bar, C into A bar, B bar, A, B, A bar, B bar, C bar. So there is 3. So that means 8. There should be 8 cells, right? So here this is A, B bar A, B, you can see, right? Or you can do this as C, B bar C, A bar B bar, A bar B, A B, B bar. So how you can map? So I will explain some trick that you can use without uh, using the truth table. So here it is A, B bar, C. So A, B bar, this bar, and C is going to true. So this should be true. B, A, B bar, C. This should be true by using this. Then this bar, A bar, B. A bar, B is here. And C bar. This should be true. And A, B, C, A, B, C. This one. And A bar, B bar, C bar. A bar, B bar, C. This one. So others should be 0. Right? This is some kind of easy way to map a given uh, sum of product expression into count maps. Please let me know if you have any problems. Then what you need to do? Then you need to this is actually the mapping. Then what is the second option was grouping. So I will explain how to do that. So grouping, there are some rules. So grouping should be done in vertically. So that means this way or this way, not diagonal. So you can't do the grouping in diagonal. Only vertical and horizontal. So it is the first one. So there are the number of the before that, when you are grouping, you can if you are deriving the answer from sum of product, so sum of product will use ones. So if you are doing that, then you need to consider only ones. So if you are need to get the answer in product of sum, then you need to consider only the zeros when you are grouping. So you will group ones, product of sum, you will group zeros, right? And you only group in horizontally and vertically, right? And when you are grouping, so each group should contain uh, cells in the 2 to the power of 2. That means, so what is the 2 to the power 0? 1. The 2 to the power 1, 2, 2, 4. So likewise, only you can group 1, 2s or 4s, right? So number of 4s and number of 1s, there should be, if you are using sum of products, then number of 1s should be according to the power of 2s. And you need to take the maximum number of group size. And the other one, you can do overlapping as what that means is if you group something like this, so that means 1, 1. And you can choose the already group cell also for the next grouping. Right. So please write these ones. So these are the rules. So other one is so that means if there is a one here and these are zeros and here also one, so you can group this way as well. and if it is 1 here, you can prove this way as well. So that means this after this row, after this edge, this will going to wrap into the here, or this will going to wrap into the here. And you need to capture, if you are using sum of product, you need to capture all the ones and the number of groups. These groups should be minimum. Otherwise, you are not going to get the correct answer. So in this particular example, so there you can find two groups. These are these ones and these ones. Right? So this is how you can do the grouping. So when deriving, so this is the grouping. So when deriving, you only need to write the unchanged variables. So unchanged steps. So here we have used sum of product. So here what is the unchanged variable? It is E bar and A bar. So A bar and C bar plus from here is C. See what is unchanged variable is E. So this is the answer for this particular example. So here in this group, B bar, BE has changed. So we can remove that part. Only need to write the unchanged letters. And here A is not going to change, only B is changing. And here C is not going to change. So it is A. So if you draw the truth table also, you can find out this is the simplified answer. So let's do another example. The previous one, x is equal to 8 plus uh, so we have only 5 minutes time. Let's see then. Yeah. So it is actually not in either sum of product or product of sums, since this B bar C So B bar C is in product of sum. So, so you need to simplify this into either total SOP of yours. So then it is going to use for mapping. Otherwise, what you can do is you need to derive the whole the truth table. Then you can use count map for the simplification. So in this particular problem, will be bit hard to use count map because not the clear map way to map this expression into the table for the count map. So I will give you another example there. So it's V bar, V bar, V bar, E plus A bar, C plus A bar, B plus H bar, B bar, C bar, B bar, C. Yeah, shall we do this one? So how we do? There are three variables. So this eight, and we need to have a of 8. So we say C bar, C bar, B bar, B, A, B, A, B bar. So A bar, B bar, C bar is 2. So A bar, B bar, C bar, this is true. A bar, B bar, C, this is true. And these are false. So as we did, we can join this one. And only C bar is changed. So that means our answer is A bar. Actually, our answer is A bar, B bar. If we take A bar, B bar out of the this expression, so it's going to be C plus C bar. C plus C bar is 1. So our answer will be A bar, B bar. Right. So next one. Uh, uh, oh, here, no. How about this one? See, right? A bar, B bar, C. A bar, B bar, C. This is true. A bar, B, A bar, B, C. This is true. And B, A, B bar, A, B bar is C bar. This is true. Here A, B, C bar. This is true. So here we can group these ones. Right. So what we comes here by using this one, A and C bar plus here C and A bar. right? So I will give you more examples as well to do the same. So consider in this example, the truth table is like this. One, this one, 0, this was it. Here, how you can do the grouping? You can group these two. So you can group, you can't group three, only two. So this, and there are one here and one here. Yeah, we can practice this two here by this. So this will be another group. Right. So in this particular example, the answer will be this one. A bar B plus this one. So C is not going to change. And B bar C. So this is the answer for this particular count. So in product of sums, as I mentioned, you need to circle the 0. That means means one. So here there are 4.